Hi, and welcome to part two of our Miticide Resistance series. I'm Sarah Hickman, the Engagement Officer with the Varroa Mite Innovation and Resilience Initiative, or VMIRI. And joining me today is Tonya Johnson, our Bee Biosecurity Officer, and we will both be presenting today's session. Before we get started, if you haven't already watched part one of this series, we highly recommend doing so as it goes into what miticide resistance is, how it occurs, and what to do next. Simply scan the QR code on the screen or click the link in the description below before continuing. Miticide resistance is an ever-changing landscape. Since February 2026, resistance has been confirmed in Queensland, New South Wales, Victoria and South Australia, but we believe it is underreported and likely far more widespread. Investigations have confirmed these resistant mites represent a new incursion of varroa into Australia. If you have any information that could assist the investigation, no matter how minor it may seem, please contact the red line number on your screen. Every piece of information could help. Samples from suspected resistant hives are being sent to Elizabeth MacArthur Agricultural Institute for genetic testing. As they're receiving samples from across multiple states, results are taking currently around 4 weeks. The key message is don't wait for your results before making management decisions. Instead, monitor how your treatment is performing. Place a sticky mat or check the tray on a ventilated bottom board 24 to 48 hours after treatment is applied. A significant mite drop suggests the treatment is working, while very few mites may indicate resistance. Alternatively, perform an alcohol wash a couple of weeks after treatment. If mite numbers remain the same or increase, resistance should be suspected. Monitoring treatment effectiveness is essential, whether you're waiting on laboratory results or not. Another testing option is available through Decentral Research and Diagnostics. They test for the L925 mutation, which is linked to resistance to synthetic pyrethroids such as Baverol and Apistan. They do not currently test for amitraz resistance, so that's your Apivar and your Apitraz. However, in Australia, we're commonly seeing dual resistance, with amitraz resistance often occurring where pyrethroid resistance is confirmed. The test costs approximately $100 plus GST, with results typically available within 24 hours of the lab receiving the sample. More information is available via the links in the description below. In 2024, before varroa was detected in Queensland, a national virus benchmarking project established a baseline of honeybee viruses across Australia. In Queensland, volunteer beekeepers helped collect samples from 83 apiaries and 270 hives. Around 70% of hives carried 4 common endemic viruses, including black queen cell virus, sackbrood virus, Lake Sinai virus, and Israeli acute paralysis virus. Why is this important? As varroa weakens bees and suppresses their immune system, these endemic viruses can become much more damaging and contribute to colony losses. As part of the current resistant mite investigations, samples are also being tested for 4 major exotic viruses, including deformed wing virus A and B, acute bee paralysis virus, and slow bee paralysis virus. To date, every sample has tested negative, helping rule out these exotic viruses as a contributor to the colony losses we're currently seeing. So while good nutrition won't prevent these viruses, it can help colonies better cope with the stresses of varroa, ensuring bees have access to adequate nectar and pollen, or providing supplementary feeding when forage is limited. It helps support their immune system and raise healthy brood and maintain colony strength. I'm going to hand it over to Tonya Johnson, our Bee Biosecurity Officer. Thanks, Tonya. Take it away.
Thanks, Sarah. So start by asking yourself, are synthetic varroa treatments working in my hives? The only way to determine this is by monitoring your varroa levels. You can't manage what you don't measure. So monitor your mite loads before, during, and after treatment. If mite numbers remain high during and after treatment, then this may indicate potential resistance. If this is your case, report your findings to DPI via BA123, the varroa email, or the DPI call centre. And as always, rotate the chemical modes of action. This includes your organic options. This will help kill the resistant mites and slow resistance development and spread. So our chemical options without resistance, we have our synthetic options, which is the amitraz products, the flumethrin and talfluvalinate. And then we have our organic options, which is thymol, oxalic acid, and formic acid. And please note, I have crossed out the Diggers Rust and Stain Remover beekeepers have been buying from Bunnings. This is an industrial grade product which goes through a different process than food grade products. It isn't manufactured or tested to a standard for bee or food safety and may contain heavy metals or contaminants not needed to be disclosed on the label. Honey is a human food product. Applying a lower grade industrial chemical creates a residue risk that could jeopardize human health. So chemical options with resistance, well, you can see it's the same, but the efficacy of the synthetic option drops, in some cases significantly. So for example, a treatment that was once 95% effective may only be 40% effective or less. It's a gradual decline as more of the mite population grows and carries the resistant genes. Research shows, though, organic options are unaffected by these resistance mechanisms, so they remain reliable tools in our toolkit. Apply rotation into your IPM plan in conjunction with mechanical options, of which we'll talk about next. So as synthetic treatments gradually lose efficacy, beekeepers are turning to organic options. However, these are less effective than synthetics were at their peak. And this is why beekeepers are finding it harder to bring mite numbers down as fast as synthetics would have. This means tighter, proactive management is essential. So what can we do to help our bees when we have high mite numbers like so? Remember, 70 to 80% of mites live under the brood cappings, hidden from most treatments until they are exposed. By forcing an artificial brood break, this removes a large chunk of that hidden population under those cappings. So how do we do this? One option is physically removing capped brood frames from the hive. So you can either remove capped brood frames and freeze the frame for 24 to 48 hours, or you can place capped brood with bees into a nuke box with a queen cell. Once that brood hatches and before the virgin queen mates and begins to lay, treat the nuke with oxalic acid, vapor or drizzle, to target the ferretic mites. Just a wee disclaimer, I don't recommend placing uncapped brood in the split like traditional methods. Uncapped brood gives varroa somewhere to hide again, and it undermines the whole point of the brood break. Another option is if you'd rather not manage a lot of nukes, you can make a larger split instead by placing capped brood with bees into a full depth box, so essentially a double brood box, and move them into a quarantine site. Delay adding a queen cell or mated queen until that brood hatches. And since a significant amount of mites will be emerging each day during that period, I recommend a longer term treatment such as oxalic acid strips paired with a fast knockdown method like the dribble or vapor for a more effective knockdown. Another disclaimer, moving these hives to a quarantine site is recommended because with such large numbers of mites emerging and being knocked down over this period, there is a real risk of drift and robbing, spreading mites to nearby hives. Keeping the split separated protects the rest of your yard while it's treated. And so finally, with these brood removal methods, the parent hive now has exposed brood and ferretic mites. Treat the parent hive the same day you remove the brood with the oxalic vapor or dribble to kill those foundress mites before they get a chance to enter the cell again. Once the remaining young larvae is capped, so before capping. Our other option is queen isolation. So queen isolation is an alternative that keeps the colony fully intact. Isolate the queen in one of these queen cages for a period of time so she can't lay new eggs. Once the existing brood has developed and emerged, the colony becomes broodless. Every mite is now phoretic with nowhere to hide. Then treat with oxalic acid vapor or dribble to kill those exposed mites.
Thanks very much, Tonya. So to summarise, we want to monitor regularly. You can't manage what you don't measure. Yes, we have resistance, but it is manageable. It's just another challenge. Brood breaks work, so utilise them. And remember, you're not alone in this. Reach out to Tonya or myself, your clubs, branches, or peers. Thank you all. Bye.
Thank you.